Okay, so the measurement of angles in radians. So again, it's just a different way of measuring. It's a different type of units for measurement of angles. So one radian corresponds to something related to a circle. So we know that a circle is basically points that are at the same distance from its center. So any circle has a center. And the points that are all at the same distance forms your circle. The distance is called the radius. So the radius tells you the distance for any point to the center. So we're going to represent the radius with usually the letter R, as you see in the drawing. Now, we have what's called central angle. So a certain angle with the vertex in the center of the circle, and then you have the initial side and the terminal side, as you see here. This is called a central angle. You just put the angle in the center of the circle where the vertex is going to be in the center of the circle. Now, depending on what is the measurement of that angle, the terminal side, the initial side of the angle, cuts a little piece of the circle, and that little piece is called an arc length. And usually we express that distance, that little slice of the circle, we usually express that with S, especially for this textbook. So S will designate a certain amount of the circle, of the distance around the circle. And R for us is going to designate the radius of the circle. Now, what is a radian? So a radian basically is the following. A radian corresponds to the angle. Your textbook gives a different definition, but let's focus on this. Is the angle that gives an arc length, arc length equals to the radius. So whatever is that measurement of central angle, that is called 1 radian. Okay, so this is a very abstract. So what is a 1 radian? The quantity is always the same, but it does not depend on the circle and the radius, right? So here's an example. So you have a circle with radius 1, and then if your radius 1, you want to find what is the angle that also gives this measurement equals to 1, right? When both radius and the arc length are equal. So whatever that measure is, that's called a radian. Now, if my circle has a different size, so the radius will be different, right? So let's say radius 3. But the angle that gives the arc length also equals to that, which is 3, is still going to be the same, which is 1 radian. So that measurement actually is about 57 degrees, or 57.3 degrees. That's approximately what is the number for 1 radian. You don't need to memorize this. This is not important, just for, so 57.3. So that's approximate. It's just an approximation. You cannot be precise. It depends on the number pi, which is irrational, so we cannot be exactly with that, right? Now that we know what a radian is, we're actually going to focus on the way to measure. So there is a way of figuring out that 1 radian has a correspondence with degrees that is much easier than 57.3 or getting a fractional number within it. We can think of a conversion measure for this measure, 2 measures, degree and radians, as 180 degrees being equivalent to pi radians, okay? Meaning, if you look at the circle, half rotation, right, half of the circle, which is 180 degrees, is the same thing as pi, the number, about 3.14, but expression in radians, okay? So that is the measure in radians of 180 degrees. And because 180 degrees corresponds to pi radians, we can say then 360 degrees, double, correspond to 2 pi radians. So that's another way of transform. So you pick and choose what you want. So the textbook give example 8 and 9, which are already, done. Please take a look. I want to actually go over an example with you. So I'm going to actually skip to example 10. Since I know that pi radians and 180 degrees are the same measure of angle, but in different units, I can use that as a conversion factor. I think more intuitive way of doing, which is actually setting up proportion. So let me do that, let's say, for example, 240, I think. Yeah, let me pick 240 because it's going to give me a nice simplified fraction there. So I want to convert from degrees to radians. And I want the answer to be in a reduced form of the fraction, meaning I'm still going to have pi in it. And it's probably going to have a fraction in the reduced form. So the way we think, so we have to convert between two angles, not what I want to write. So I have degrees and I have radians, right? So what do I know? My angle right now is in degrees. So 240 degrees, I need to figure out what's the equivalent, x, unknown, in radians. But what do I know? I know that 180 degrees corresponds to pi radians, right? And by the way, you don't need to put rad like I do. If you don't put anything, it's automatically become radians. The only measure that for angles that you need to specify is actually degree, which you specify the upper script, little o, like in temperatures. But if you don't, if I write just 180 without anything, that means automatically radians. So there's no need for specifying radians, but there is a need to specify degrees, okay? So, but if you think it's better for you to write like rad or radians, that's up to you. Some textbook write like this just to look like the degrees. They write the upper script, little r, just to specify, okay? Okay, so my answer should be in the reduced form, fraction in terms of pi. If there doesn't ask pi, it needs to approximate, and then we're going to use the approximation for the number pi. By the way, this is the constant that we all know about 3.14, and most of the calculators have that number there with more digits, right? If I need to approximate, I'll use that 3.14 and a change. If I don't need to approximate, I need more an exact value, I'll leave pi alone in the answer. Okay? All right, so I know this is my way of proportion. So meaning my proportion now is I'm going to take the 240 degrees divided by 180, and should be the same as x that I need to find, divided by pi, which is in radians, right? So if you cross multiply, you're solving for x. I'm writing all the details here. Again, you can skip the steps as long as you understand what's going on. So 180 times x, and then I have 240 times pi. Obviously, the answer will be in degrees because basically this, this unit here cancel with this unit in the fraction, so it becomes a number. So that's why I stopped writing the little o. And so I needed to solve for x, so now I'm going to divide both sides. Notice that I'm doing all the steps, but again, you don't need to do that. Going through all the steps here to be sure that you get the idea. So my answer x will come from this fraction. The problem asks to reduce to lowest terms. So definitely I can reduce by 10, both numbers, so it becomes 24 over 18. 24 can be divided by 3. Let me see, I'm doing my head. By 3, I get 8. This by 3, I get 6. And I still can reduce 8 and 6. Notice that I'm doing the long computation. 8 can be divided by 2, I get 4. 6 can be divided by 2, I get 3. I cannot reduce no more, right? So my answer in the reduced form here, in the reduced form of the fraction, is the leftover 4 over 3. Notice that pi is still there. So 4 thirds pi radians is the same as 240 degrees. Right? So note, again, always pay attention to what the problem is asking you. In some problems in your next homework, the real homework that you use for this, sometimes you're going to just have to write the fraction. No, the pi will be part of the answer already. You don't have to write pi, but you're going to have to write the fraction in the reduced form. Sometimes the problem will ask you to approximate to a certain number of decimal places. So if approximation is required, then you take the 4/3 and multiply pi, the number 3.14 and a change in your calculator. Okay. Now, careful. When you're doing this computation of rounding the number, let's do this here for this problem. This is the answer according to what the problem is asking. Right? So it's 4 pi over 3, or 4 over 3 times pi. It's up to you how you want to write. This is the same thing. That is the same as the 240 degrees, but in a different unit. But if the problem say, hey, now you're going to approximate this to 4 decimal places. So you take your calculator, either online or a real calculator. I'm going to do the 4 division by 3 times the number pi, which my calculator says, if I use more decimal places, it's going to say 3.14, 15, 9, 265. Notice it's a lot. So I'm using the whole thing. Because I'm doing this in the calculator, you don't have to write this down if you're doing this in the calculator. Why? Because I want you to be more precise with your answer as possible. So if you only use 3.14, you're going to lose a lot of precision. And the problem with losing precision is that when you put your answer into the system, the computer is going to say wrong because you lost a lot of precision. So the numbers are far in the decimal places. Okay, so try to always use as many decimal places as possible. And the system is going to say, now, after you got your answer using this huge number of decimal places, which I'm going to do now, then you round. But do not round in the beginning, you round in the final stage of the computations, okay? So this answer should be approximately, my calculator say 4.888790,204. I'm not going to put everything, but let's say the system say, hey, round to 3 decimal place, meaning this is the place I want to round for, but I need to look what's the next one. If that is 5 or more, you increase the previous one. So it is 7, which is more than 5. So the answer is approximately 1.89. So I increase this part here because the next one is big enough to make that bigger. Okay, so just pay attention to that. If the system say 2 decimal place, and then you look at the 2nd decimal place and 3rd decimal place and so on. But do not round the numbers in the beginning of the computation, only towards the last stages of the problem, right? You don't want to lose precision, and that may be a problem for the homework online. You may be doing everything correct, but you have no clue why you're getting wrong answers all the time.